Hi, this lesson is about dividing polynomials. If p of x and d of x are polynomials where d of x is not equal to 0, then there exists a unique polynomial q of x and possibly r of x such that p of x divided by d of x equals q of x plus r of x over d of x. R of x is what we call the remainder. Not all division problems will have a remainder. But if it does, it could be either a constant or it could actually be a function of x depending on what you're dividing. And we call q of x the quotient. The numerator is called the dividend. The denominator is called the divisor. That is the expression that is doing the dividing. So we will be doing this by both long division and synthetic division. We start with long division. So I have 6x squared minus 12x plus 13 divided by x minus 4. The first quadratic expression is the dividend, and x minus 4, the linear expression, is the divisor. So you put the divisor on the outside of the fraction bar and the dividend on the inside, and then you're taking the first term on the inside and dividing it by the first term in the divisor, and that result is 6x. That gets written right above the x term in the original dividend. And then you have to multiply 6x times x minus 4, and we get the next result, which is 6x squared minus 24x, because it's 6x times negative 4. But then that expression has to get subtracted from the one above. So that minus sign is going to get distributed across. So the 6x squareds will cancel each other out. And then negative 26x, and that 24 will become a plus 24x is equal to negative 2x, which is on the next line. And then you bring down the next term. Then you repeat the process. Take the first term in here, divide it by the first term on the outside. That gives me a result of negative 2. So you write minus 2 in the divisor above the dividend. And then you multiply negative 2 by x minus 4, and I get negative 2x plus 8. But that also needs to be subtracted from what's above it. So the 2x's will cancel, and 13 gets 8 gets subtracted from 13 when you distribute the negative. So I get 5 as my remainder. So the answer is 6x minus 2 plus 5 over x minus 4. 6x minus 2 is the quotient, and the remainder is 5, and you put that over your dividend. Okay, so now we're going to divide 8x to the fourth plus 6x squared minus 3x plus 4. Notice that this time I have a fourth degree polynomial as my dividend, but I do have a missing term. The x to the third term is missing, so I'm going to have to hold a place for that. It goes straight from x to the fourth to x squared, so I'm missing x to the third. And it's going to get divided by this quadratic expression, which is your divisor. So again, the divisor goes on the outside, and the dividend goes on the inside. I'm holding a place for the x cubed term by putting a 0 in front of it, and that keeps things organized so that like terms will line up properly. Then you repeat the process I did in the first example. You take the first term on the inside, divide it by the first term on the outside, and that gives me 4x squared as my answer. That gets written above the x squared term in the dividend. Then multiply 4x squared across your divisor. So 4x squared has to get multiplied by these three terms. And so that gives me what you see on the next line, 8x to the fourth minus 4x to the third plus 8x squared. So again, we want that 0 there so that the x cubed terms line up properly. And then you have to subtract. And again, when I subtract, that minus sign is going to get distributed all across what you see inside of those parentheses. And so the x to the fourths will cancel. The x cubed becomes 4x cubed, and then minus 2x squared, and then bring down the next term, including the sign in front of it. So you bring down minus 3x. Repeat the whole process again. Take the first term in here and divide it by the first term in the divisor, and that gives me 2x as an answer. So that's a positive expression, so you put plus 2x in your divisor, and then you're going to distribute the 2x across your divisor, and that gives me what's inside of the parentheses here, which is 4x to the third minus 2x squared plus 4x. And then again, just like we did with all the previous examples, I then have to subtract that from the line above. So the 4x cubes cancel, the 2x squareds cancel, and I'm left with a negative 7x. And then you bring down the next term. Okay, so this expression is the remainder. So this is a remainder that's actually a function. It's not just a constant. So my answer is 4x squared plus 2x plus negative 7x plus 4 over your divisor. Or you can factor out a negative from here. And so this becomes a minus here. So 4x squared plus 2x minus 7x minus 4 over your divisor, both of those answers are equivalent. So either one is fine. Okay, so we go on, and now we're going to practice dividing by synthetic division. We'll get the same results with synthetic division, but the steps are a little bit different. So it's faster for the most part, but it works nicely when your divisor is a linear expression, not when your divisor is a quadratic or higher. Synthetic division doesn't work out quite as nicely. So when your divisor is a linear expression like we have here, we're going to use synthetic division. So the technique is that your divisor has to be in the format of x plus or minus some number. If you have a coefficient in front of x here, then there's another step we're going to have to do. We'll do that later on. So you put the opposite sign of the number associated with the x, which in this case is 4, out on the outside. And so you're going to put the 4 and then put a bar like this. So it's different than long division where we have a bar like that. And then you put the coefficients and the constant of your dividend, and they have to be in the right order with the highest exponent first all the way down to the constant. So then we write 6, negative 26, and 2 inside this bar, and then we draw another line right here. So that's what you're seeing over here. Then the first thing you have to do is copy down the first number below that bar, and then you have to multiply 6 times 4, and that goes in the in-between area. That number gets added to the one above it, so I get negative 2 as a result. And then I multiply negative 2 by 4, and that gives me negative 8. So your products are going in that in-between section. And then I add those two numbers, and that gives me, sorry, I copied this wrong. This is a 12. And that gives me 4 as a result. So this is the quotient, and this is my remainder. And so my quotient is 6x minus 2 plus 4 over x minus 4. Your quotient should be 1 degree less than what your dividend is. So that's how I knew that I was going to have an x there and not an x squared or an x cubed or something else. So it should be 1 degree less than what you started with in your dividend. Okay, so we'll do another one with synthetic division. Here we want to evaluate p of x divided by d of x, where p of x is 3x to the third plus 9x squared minus 5x minus 1, and d of x is x plus 4. So my divisor is a linear expression with the leading coefficient of 1. So that's good news. So we put negative 4 on the outside. You always want to put that opposite sign there. And all of the coefficients and constants here in the right order. So I have 3, 9, -5, and -1. These have to be in decreasing order in terms of exponents. This is x to the first and then constant at the end. If they're jumbled up and you put them in the wrong order in your synthetic division, you're not going to get the right answer. All right, so first step is copy down the first number and then multiply 3 times -4. That's where we get -12. That -12 gets added to the 9. That gives me -3. Repeat the process. -3 times -4 gives me a +12. Add -5 and 12 and you get 7. Take that 7, multiply it by the -4. That gives me -28. -1 and -28 gives me a remainder of -29. So remember, my original expression here, the p of x, the dividend, is a third degree polynomial. So this one here is going to be a second degree. So that's 3x squared minus 3x plus 7. That's your quotient, minus 29 over x plus 4, your remainder. Okay, so in the next example, here I wanted to show you that it is possible to check your answer by taking your quotient and multiplying it by your divisor and then adding in your remainder, which was -29. And it should bring you right back to your dividend. So I did that work here. I did x plus 4 times 3x squared minus 3x plus 7, and then I took 29 away. So you have to multiply these out first. So you have to distribute the x, then distribute the 4. So when I distribute the x, you get these 3 terms. When I distribute the 4, you'll get these 3 terms, and then the minus 29. When you combine like terms as much as possible, you get 3x to the third plus 9x squared minus 5x minus 1, exactly what our p of x was equal to, your dividend. So if you're not sure if you're on the right track, you could always check your answer by just multiplying the quotient by the divisor and adding in the remainder. If your remainder is 0, you don't need to do this extra step right here. You would just multiply. Okay, so any problem, either done by long division or synthetic division, can be checked by multiplying the quotient and the divisor, then adding in the remainder. And it should give you back your dividend, which is what we're calling p of x. Okay, here we want to simplify negative x to the third minus 2x plus 5 over x plus 1. So this basically means divide them. There's really nothing else you can do other than division. And this could be done with long division or synthetic division. I'm going to use synthetic division. But I wanted to show you this one also has a missing term. This goes from x to the third to x. So I'm missing an x squared term. So with long division and with synthetic division, you want a placeholder for the x squared. So when I write in my coefficients and my constant right here, you are going to put -1, 0, -2, and 5. And on the outside, you put the opposite sign of that number. So it's -1. And then I'm going to repeat the steps that I did in the last two examples. Copy down the first number and then multiply -1 and -1. That gives me 1. Add 0 and 1 and you get the 1 directly below. Multiply 1 by -1 and you get -1. -1 and -2 add up to -3. Multiply -3 and -1 and I get +3. Add 5 and 3 and you get 8. 8 is your remainder, and this is going to be a second degree polynomial. Remember, we started with third degree. So this is -x to the second plus x minus 3 plus 8 over x plus 1. Okay, so in this next example, this is the first time that I have a divisor that my leading coefficient is not 1. I have a 3 in front of the x. And so I mentioned earlier that that means that you're going to have to do an extra step. And actually 2 extra steps, one at the beginning and one at the very end, but they're basically the same step. So since 3x minus 1 is not in the format of x minus c, we can rewrite it by dividing the 3, this is a plus by the way, we can divide the 3x plus 1 by 3, which will give me x plus a third, which is now in that form. My leading coefficient is 1. So I divided by 3 to force it to look the way I need it to look. So I put the opposite sign of this here on the outside, negative a third, and then I write down all of these coefficients and constant here, and then repeat the process. Multiply 3 times negative a third, that's negative 1. Add negative 14 and negative 1, I get negative 15. Multiply negative 15 by negative a third, and I get positive 5. Add negative 5 and 5, and that means I have a remainder of 0. So my quotient is 3x minus 15. But if I divided the original divisor by 3, you're going to have to divide this one by 3 as well. And so your answer is actually x minus 5. So the first expression divided by the second expression is equal to x minus 5. Okay, so that extra step of dividing by 3 is only when the leading coefficient of the divisor is not 1. All the previous examples I did with synthetic division just had an x or a 1x. This is the first time we have something in front of the x other than 1. So the next example is, again, my divisor is 2x minus 5. So again, before I start, I have to divide the divisor by 2. So when I do that, you'll get x minus 5 halves. Then positive 5 halves is written on the outside, and inside the bar, you're putting these coefficients and constants. So you put 2, 1, and negative 14 inside of the bar. Copy down the first number. Multiply 2 times 5 halves, that gives me 5. 1 plus 5 is 6. 6 times 5 halves, the 2 will divide into the 6 3 times, so that gives me 15. So that goes here. Then negative 14 plus 15 gives me a remainder of 1. So when I take this, I'll get 2x plus 6 plus 1 over x minus 5 halves, because remember, this was the divisor we were working with. But I still need to divide that by 2. Just like here, I divided by 3, I have to still divide this whole thing by 2. Dividing by 2 is the same as multiplying by a half. So when I divide by 2 or distribute the 1/2, I will get x plus 3. And here, when I multiply this whole thing by a half, you'll get 2x minus 5. The 5 halves, the 2 and the 5 halves will cancel with the 2. Okay. Again, here I checked it just to show you that you can do a check by taking your answer and multiplying it by your divisor. So I'm going to take this answer that's now fully resolved. I divide it by 2, take the original divisor, and then I'm going to add in my remainder, which is 1. So when you multiply this out, you want to FOIL it, you'll get 2x squared plus x minus 15 plus 1, and that gives me an answer of 2x squared plus x minus 14. That's exactly what we started with when we, as our dividend, when we divided. So if you didn't make any mistakes, that's exactly what you should get in the end. Okay, so there is more to this lesson. We're going to learn a theorem called the remainder theorem. And with this remainder theorem, we can use long division or synthetic division to help us um, figure out this information. And so first, let me explain what the theorem says. So if the polynomial p of x is divided by x minus c, then the remainder is the value of p of c. So whatever you get as a remainder, that is going to be the value of the function, the original function, that the dividend at p of c. Again, this would be the opposite sign. So let me go back here. I got a remainder of 1, and my c was 5 halves, because it was x minus 5 halves. So p of 5 halves equals 1, which means that if I were to plug in 5 halves in here, I would get 1 as an answer. So it's basically giving you the value of one function, of one point on the graph of the dividend with this remainder theorem. So sometimes that could be really handy if you're trying to graph a polynomial. And 2x squared plus x minus 14 is a polynomial. So this only works for polynomials, not rationals or radicals or other functions. So we want to use the remainder theorem to evaluate p of c, where p of x is equal to 4x squared plus 12x plus 5, and c is equal to negative 1. So if I can figure out what the remainder is when I divide this expression by negative 1, then I'll be able to answer the question. So I write 4, 12, and 5 inside of the bar. Copy down the 4, multiply 4 times negative 1, I get negative 4. Add the 12 and negative 4, and I get 8. 8 times negative 1 is negative 8. 5 plus negative 8 is negative 3. Negative 3 is my remainder. So what that means is that p of negative 1 equals negative 3. Now, I could also find that information by just plugging in, taking this function, plugging in negative 1 in for x, and I should also get negative 3 as an answer. So here I did the work for it. So I have 4 times negative 1 squared plus 12 times negative 1 plus 5. That leaves me with 4 minus 12 plus 5. 4 minus 12 is negative 8, and negative 8 plus 5 gives me negative 3. Same answer that I got here. Okay, so you don't have to do it both ways. I just wanted to prove to you that I get the same answer by either using division, synthetic division, or by just plugging in the number and evaluating what that polynomial is. So here I want to evaluate p of 2 using the remainder theorem. So again, that means I'm going to divide this 2 into these numbers here using synthetic division. I just took those numbers from my third degree polynomial up here. Copy down the 1. 1 times 2 is 2. 3 plus 2 is 5. 5 times 2 is 10. Negative 7 plus 10 is 3. 3 times 2 is 6. 6 plus 6 is 12. So that means that when x is 2, p of 2 is equal to 12. So that would be a point on the graph, on this graph. It would be the point 2, 12. Okay. So that's it for this lesson. Good luck.